So let's look at work and power. Work is the transfer of energy through motion when an object moves over a distance. So as something moves over a distance, we are going to transfer energy. And work is going to equal F, which we learned last unit is force. D is the distance. And W is the work. And again, you don't necessarily need to memorize this equation because it is on your reference tables. Work equals force. Remember that triangle means change, so that's simply a change in your distance. And so let's do some example problems, and we're going to need to set up our triangle. Always want a triangle when we set up these problems, okay? Anytime we do a math problem, we want to make sure we have a triangle because this triangle really helps us to clarify what we need to do. Force and distance are being multiplied, so force and distance. And then here at the top would be my work. How much work is done by a woman lifting a 100 Newton suitcase, 0.5 meters? Okay, so remember force is in newtons, so there's my force, and here's my distance. So to cover up work, I do force times distance. And so that means I'm going to have 50 joules of work. So joules is also how we measure energy. So work and energy have the same unit. Make sure you remember that. Work and energy have the same unit. All right, a student's full backpack weighs 40 newtons. All right, that is the force. And we know force are, let me stop. The student must lift the pack 1.5 meters. How much work is done on the backpack full of books? Okay, so for work, again, we're going to do force times distance. So here's my force. Here's my distance. And when I plug that into my calculator, I get 60 joules of work. So power is the rate at which work can be done in a given amount of time. So power is the relationship between work and time. So if work is force times distance, then I can rearrange my equation here. Force times distance we know is work. So power is work, which we're going to measure in joules, per time, which is in seconds. Now, power is going to have the units joules divided by seconds, which we also call a watt. And think about that. What are your light bulbs that you put in measured in? Light bulbs are measured in watts. And if the power goes out, do you have any light bulbs working? No. So what is the power of a motor that does 4,000 joules of work in 20 seconds? So power is work divided by time. So I have to set up my triangle. Work is being divided by time. So work divided by time, making my power go in the section that is blank. So what is the power? I'm going to take my work of 4,000 joules, and I'm going to divide it by time. And so that gives me 200 watts of power. Now, because work is force times distance, it is possible I give you the force and the distance. So you could have a triangle as well. where we rearranged work to show us that it is force times distance. So there's my power divided by time. And we know that force is mass times acceleration. Oh, holy smokes, we could even do a whole nother triangle where where force is mass times acceleration. So there's my force times distance divided by time. So there's a lot of different ways I can give us power problems and ask us to solve them.